Hello students, I am Dr. Vibha from SRMCM, Lucknow. Today I am delivered our 29th lecture. There is a HallEffect transducer and measurement of motion. So, as you know, the transducer is the device that converts one form of energy to another form of energy. In previous lecture we discussed the piezoelectric transducer. This is the HallEffect transducer. This is the electromagnetic transducer. We have discussed the pressure transducer. We can discuss the linear variable transducer. We discuss the strain gauge transducer. Now coming to this is the electromagnetic transducer. This is HallEffect transducer. This is known as the we can't measure electromagnetic directly. We can using this transducer. So, we discuss the basic concepts and of the working of the HallEffect transducers, and the second part we can consider here is the motion sensors, or you can say the transducer. How can the measure the motion? So, this I will cover in this lecture also. So, first we discuss about the HallEffect transducer. So, you know the Hall element is the type of transducer used measuring the magnetic field by converting into an EMF. This point is important. We can consider the field by converting into an EMF. The direct measurement of the magnetic field is not possible. As earlier told you, thus the HallEffect transducer is used. The transducer convert the magnetic field into an electric quantity, which is easily measured by the analog form or digital meters or as per requirement in other parameter also. So, there is the importance is not magnetic field is never measured directly. We can convert it into this electric quantity, and then we can measure in the analog meter or digital meter. So, what is the principle of HallEffect? Before going to the here we are discussing about the HallEffect transducer. So, there is a parameter where you consider as the HallEffect. What is HallEffect? So, with the principle I am discussing not exact HallEffect, the principle of the HallEffect, that when a current carrying conductor or a semiconductor is introduced, the perpendicular magnetic field of voltage can be measured at the right angle to the current path. We consider when we consider the HallEffect, we consider two laws in between, Lorentz law and Fleming left hand rules. तो वो भी यहाँ पे we can consider करते हैं. This effect is obtained measurable voltage is known as the Hall effect. So, with the help of this, again repeating, Hall effect is that when a current carrying conductor or semiconductor is introduced to a perpendicular magnetic field, a voltage can be measured at the right angle to the current path. This is your known as Hall effect. So, this voltage is that is known denoted by VH. This is the HallEffect voltage. तो in between we can consider the Lorentz law also, कि जब हम उसके अंदर कोई है magnetic path create कर रहे हैं, तो we can just this is the north pole, this is the south pole. So, there is the some, so we can apply the force. So, there is diverted that lines. तो ये हमारा जिस तरह से फोर्स डाइवर्टेड होता है, तो वो कंसिडरेशन करेंगे. एक पॉइंट. दूसरा फ्लेमिंग रूल लेफ्ट रूल भी लेते हैं, बट वी आर आई एम नॉट डिस्कसिंग अबाउट द लॉरेंस लॉ एंड फ्लेमिंग रूल, बट वी कंसीडर इन द HallEffect प्रिंसिपल्स. वहाँ पे हम उसको यूज़ करते हैं. ब्रीफली यहाँ पे हम आपको डिस्कस कर रहे हैं कि वी कैन दिस इज द हमारा जो भी है वो हॉल एलिमेंट है. यहाँ पे वी आर अप्लाइंग द मैग्नेटिक फील्ड, देयर इज द चार्ज. वी कैन कंसीडर दिस इज वी आर जनरेटेड द voltage. That voltage is known as your HallEffect, or you can say the HallEffect voltage. So, we can consider here that this only principle, but we consider when we talk about the HallEffect, we can in the mind also the Lorentz law as well as the Fleming left rule. We hear the working, we discuss the working, that is very important. The whole thing is depend on this. The circuit is, you have seen there is the Hall step. Okay. There is the transmagnetic field, we can generate, there is a 4 point 1, 2, 3, 4. So, we are passing the current, we are generating the current, and that conductor, this conductor you are using, that time pass the magnetic field. जब magnetic field pass कर रहे हैं, तो हमारे जो थर्ड नंबर टर्मिनल है और उसके बीच में क्या होगा, हमारा पोटेंशियल डिफरेंस जनरेट होगा, और उसको हम यहाँ पे मेजर करेंगे. ये हमारा क्या होगा, जो वोल्टेज इज HallEffect वोल्टेज. जो हमारा स्ट्रिप हम यूज़ कर रहे हैं हॉल स्ट्रिप, उसकी थिकनेस कितनी है, दैट इज़ योर T. तो अब हम आगे पूरा डिस्कस करते हैं. कंडक्टिंग स्ट्रिप इज केप्ट इन अ ट्रांसफर मैग्नेटिक फील्ड मटेरियल. दिस स्ट्रिप इज कंडक्टिंग, प्लीज नोटेड. नॉन कंडक्टिंग मटेरियल नहीं, द स्ट्रिप इज कंडक्टिंग. Note that the current through the strip and the magnetic field are perpendicular to each other. Magnetic field are perpendicular. Flow of current means the flow of the charges in the direction of current. ये आपको यहाँ पे दिखा रहे हैं. You can see that this is the direction of current. You can hear this one and this one also. उसमें बनाया नहीं हुआ, so you can measure this one. Then this means magnetic field exert a force on the moving charges as per the equation. This is F is equal to Q into V into B. That is your velocity of charges. This is Q. This is the magnetic flux. The velocity and status of the magnetic field or VB or there is the vector form. Which is vector form? Since V and B are the perpendicular to the each other, the magnitude of the force moving positive charge will be F is equal to QB. The direction of force will be perpendicular to both V and B. The important parameter is the direction of force, that is important. If you not consider direction or perpendicular, it will not generate the voltage. So we can consider directed from the S3 to 4 जो कि हमें मिलती है, we can consider from the point 3rd and 4th. इसके पहले figures में discuss किया. Due to force of positive charges, these charges will continue to accumulate on the phase 3. एक जब आप याद करिए उसका, अगर वहाँ पे हम फ्लेमिंग लेफ्ट हैंड रूल की बात करेंगे तो वहाँ पे जो हमारा इस करते हैं, तो वी कैन कंसीडर दिस वन. तो यहाँ पे हमारी जो होता है वो ज़्यादा कलेक्टेड होता चला जाता है. वी कैन कंसीडर क्योंकि जो फ्लेमिंग लेफ्ट हैंड रूल है वो वर्क करता है पॉजिटिव के लिए. हमें क्या कंसीडर करें, उसका डायरेक्शन चेंज होता है, वी कंसीडर द निगेटिव. तो दिस पॉइंट सेज फेज 3 विच इन टर्न विल क्रिएट एन इलेक्ट्रिक फील्ड. द डायरेक्शन ऑफ द फील्ड विल बी द अपोजिट टू द डायरेक्शन ऑफ magnetic field. जो magnetic field अगर this is working for this side, then electric field working on this side. तो ये these are the important parameter at the time of the Hall effect. So the 3, 4 therefore after some time magnetic force exerted by the electric field and the force will be become equal and hence there will not be any further movement of the charges. जब ये कंडीशन ऐसी आ जाती है, दैट इज नोन एज अ सैचुरेशन. वहाँ पे हमारा कोई भी मूवमेंट चार्ज का नहीं होता है दैट टाइम इन कंसीडर एज द दिस इज और इलेक्ट्रिक फील्ड. तो वी आर Q इज इक्वल टू F ई. अब Q वी नो द Q E इज इक्वल टू QVB. वी कैन कैंसल द Q की, then consider the EVB. Due to the setup of the electric field in the conducting strip, that consider potential difference is generated and this is known as your हॉल इफेक्ट. दिस इसके पहले भी आपको अपने समझाते हैं. वी कैन कंसिडर दिस वन, दिस इज योर हॉल इफेक्ट. तो वी कैन ड्रॉ इट, वी कैन कंसिडर इट. तो थोड़ा और द T इज द स्ट्रेंथ ऑफ द पोटेंशियल डिफरेंस 3 and 4 गिवन. So remember that we can measuring the Hall strip when we are using the diagram. We consider the measuring point is 3 and 4 and force applying point is 1 and 2. तो अब जहाँ पे अप्लाई करें दैट पॉइंट इज 1 and 2 एंड मेजिंग पॉइंट इज 3, 4. दैट्स व्हाई वी कंसीडरिंग द 3 and 4 पॉइंट. तो द E is H is equal to ET is equal to BBT. Since the current density through the material is directly proportional to the velocity of carriers through, so V is equal to KHJ. We are driving this situation how will we create that effect. So KH, there is a this KH is a constant of proportionality called the Hall effect coefficient. What is Hall effect coefficient? That is KH. But J is equal to IA, where A is the surface of area. Therefore, J is equal to I by T by 2. Hence, the information KH, this is the KH I into T2. T is the your distance of the strip. There is again Hall effect. This is known as there is some AH is equal to KH IB divided by T. So gives the voltage developed due to the Hall effect. This create the voltage developed due to the Hall effect. This is the main. So this voltage is called the effect EMS and use the entire measurement of magnitude in the current of the magnetic field strength. So these are the measurement patterns when we are using the Hall effect transducers. This concept give the for the Hall effect transducer. जब हम Hall effect transducer में कुछ मेजर करते हैं तो इस तरह से वर्क करता है. तो the magnitude of Hall effect is very small जितना भी हम जनरेट करते हैं तो दैट इज द वैल्यू इज वेरी स्मॉल व्हेन क्रिएटिंग हॉल इफेक्ट वोल्टेज that value is very small. We can consider as the some difficult to measure, we can't measure in a easy way. So, we can change in the other circuits and use for according the requirement. जैसे हर ट्रांसफर में होता है कि we generate उसे amplify करते हैं सिग्नल को, that point this is the sufficient for the semiconductor and measured by the sensitive moving coil instrument. This is the basic working of the your Hall effect. We can consider the concept of the Hall effect, where when you are using the Hall effect transducer. So, this is the whole unit of the Hall effect transducers. You can see here. So, this is the working principle. Application of the Hall effect transducer is very important. You can use the piezoelectric, you can use the LVDT, we can use the different transducers, but here is the application part is very important. क्यों? क्योंकि they are the dedicated field, not magnetic field हर जगह generate नहीं होती है. तो the application of the Hall effect transducer is very dedicated. The first is your magnetic autoelectric transducer. The Hall effect element is used for the converting the magnetic flux into the electric transducer. इसके पहले भी यही डिस्कस किया है. The measurement magnetic field, the voltage derived at the end of the semiconductor steps, जो हमने वहाँ पे भी आर मेंशन द स्टेप मैग्नेटिक फील्ड डेंसिटी. अब हॉल इफेक्ट ट्रांसफर क्या करता है, वी आर टेकिंग द स्मॉल स्पेस गिव द कॉन्टिन्यूअस सिग्नल कंसिडरिंग द मैग्नेटिक फील्ड स्ट्रेंथ. वी कैन कंसिडर दिस टाइप ऑफ हॉल इफेक्ट ट्रांसफर. वी कैन डायरेक्टली मेजर द magnetic field with the help of the electric transducer. Which transducer? We can consider the Hall effect and measure the magnetic field. सेकेंड है मेजरमेंट ऑफ पावर. अगर हम बात करेंगे, आपकी डायग्राम देखिए, तो वी आर इज डायरेक्टली प्रोपोर्शनल टू द जो मैग्नेटिक फील्ड आपकी वो किसके हॉल इफेक्ट वोल्टेज. तो जो ई एच है, ई एच जो हमारा होता है हॉल इफेक्ट वोल्टेज है, वो क्या है, दैट इज आल्सो डायरेक्टली प्रोपोर्शनल टू योर पावर. हियर इज द यूजिंग डायरेक्टली we can consider जो आप करेंगे, we can consider that directly measuring the Hall effect transducer used for the measuring the power of the conductor. The current is applied across the conductor which develops the magnetic field. The intensity of the field depends on the current. The magnetic field induces the voltage across the strip. The output voltage is proportional to the power of the transducer. You can remember that diagram, first diagram where I considered the Hall effect voltage. We mentioned the EH. Please remember always, this is directly proportional to the power. This is the important application for the power measurement of any device, especially for in conductors. Third is your measurement of displacement. Again, क्योंकि all transducers measure for the process variables also, then we consider as the displacement. The Hall effect of element measure is the structural element. For example, considering the ferromagnetic structure which has a permanent magnet. There is the example you have seen, the this is our permanent magnet. We can consider the structure member. Structure member have a permanent magnet. In permanent magnet, we can consider a gap, and that gap we are using the Hall effect element. We put it the Hall effect element. क्योंकि for the Hall effect, the consideration is we measure the magnetic field. We can consider the magnetic applications. Then there is a structure which have a permanent magnetic gap. That magnetic gap we are producing a Hall effect element. Or this is our displacement. When we changes this position of the this plate, or you can say this strip, so their position will be changed and the effect will be changed. The gap between the your magnetic gap between the and the magnetic plate है. If we move this plate that side and this side, so one side is the increasing the voltage EMF Hall effect voltage, and that time will come the decreases the Hall effect voltage. So, this is the measurement of displacement, which at that displacement where we are considering the magnetic field, ferromagnetic structure we are considering, at that time we want to measure the displacement, that time we are using the Hall effect transducers. That is why I am saying these are the dedicated transducers. dedicated application for the HallEffect transducer, not for everywhere. The fourth is the open and closed detection of laptop flip screen and the conserve the power while the switching laptop of sleep mode. We are considered as the not we consider the when we heavy duty, when we consider the your piezoelectric, but for the normal laptops we can consider here the flip screens. Then the laptop in the sleep mode we can consider this one. You can see that there is the blinking. So, there is some field in the magnetism is there. When the laptop is not off condition, this is on, but in sleep mode. Variable of speed drivers, flow meters. When we discuss the flow measurement, that time we also consider the flow measurement where this is the magnetic, paramagnetic ferromagnetic we can structure, we can ferromagnetic flow. That time we are using the this HallEffect transducer. Encoder switches, using the motor control, protection, indicators, measurement of current. Then again another important parameter for the HallEffect transducer is a great way of following the circuit without actually interrupting the circuit. You can consider displacement measurement, we can consider the power measurement, we can consider the magnetic measurement and the lot of different domestic uses also, but there is another important measurement is your with the help of the HallEffect is the current measurement. Here we can consider the this application actually connection between the circuit whose current is to be measured in the meeting the instrument. Normal you can measure with the help of your ammeter, but at that time we are consider the transduce function and the condition is the ferromagnetic system. At that time we are using the HallEffect transducer for the measuring of the that current, that ferromagnetic tube, ferromagnetic system, ferromagnetic structure, there we can using the this. So, here we consider the ferromagnetic tube, this ferromagnetic tube is called as your magnetic concentrator. You have seen here in this diagram, this is your magnetic concentrator, this is the or you can say the ferromagnetic tube. We are considering that this is the conductor, we are moving in this side where in the this tube the current is heavy current, not a very low current, they are using the heavy current. So, the conductor magnetic field created the current carrying circuit element. You can see that this is the conductor, that strip is light strip and the tube, this is known as concentrator. So, we are considering is the HallEffect. तो जब कंसीडर बिलो द डिफेक्ट वी कैन कंसीडर चेंज होती है, ऊपर से आपका फोर्स पड़ रहा है, जिस हिसाब से करंट जा रही है, वी कैन चेंज इट, वी कैन प्रोड्यूस अ वोल्टेज वेयर प्रोड्यूसिंग द वोल्टेज concentrated magnetic concentrator or you can say the magnetic ferromagnetic tube. So, we can consider for the conductor is carrying current may be AC or DC, is not a boundation, it is measure only AC or measure only DC, any type of consideration. Create magnetic field around it, the value of this magnetic field proportional to the current and given the Biot's Savret law. When a HallEffect element is perpendicular the magnetic field in the slot of the ferromagnetic concentrator, a HallEffect image is produced and given by जैसे उसमें दे रहे थे the magnetic of the proportional current flowing in the conductor. This thus the measurement of EMS across the HallEffect transducer can the magnitude of the current flowing the circuit. In especially the same principle is not changed. We can consider the force, we can consider the magnetic flux, we can consider the charges, but there is the dedicated device. We can consider a tube, they have the ferromagnetic tube, they are known as the magnetic concentrator, then using the pass the conductor at that tube, then can generate the HallEffect or we can measure the current. This is the important application of the your HallEffect transducers. Now, again coming to the advantage disadvantage, this is the high speed operation over 100 kilohertz possible, that is a very high speed operation in the HallEffect transducers, and when 0 speed, if you have a 0 speed, that can you also measure the voltage at that 0 speed, highly repeatable operation, we can repeat, repeatability property is also very good, capable to measuring the large current also. Though dedicated application hai, so we are last application we discussed the current measurement with the help of the Hall effect. In the specific case we are consider the ferromagnetic structure, that time we capable in the large current. We can enter the large current also then in the magnetic concentrator. Just discussed before this advantages, we consider the magnetic concentrator that the capable of measuring large current, but they have some disadvantage. External interfering magnetic field effect karega, temperature drift, according to temperature we can change the, and we have to produce the large offset voltage. So, these are the disadvantages. Every transistor have a you can see the almost all transistors they have a temperature effects. This is the disadvantage part of that Hall effect transducer also. If temperature changes, the value will be changed. Now, coming to the motion sensors and transducers, again discuss the before discussing this motion sensors and transducer, we can tell about that we are using almost we discuss the different type of transducer. Now, coming to the measurement part, how can use these transducer to measure different values, different process values, process parameters. So, at this time we can consider motion sensor as the measurement of the motion. As you know, the physical characteristics define the motion in the form of displacement, velocity, accelerations, or related quantities or vibrations, shocks, that we can consider the motion measurement. But how can we use the different transducer for the measurement of the motion? So, we can decide the dedicated motion sensors or motion transducers. So, we can consider almost you heard about the before resistive potentiometer, I will discuss LVDT, variable capacitance, variable inductor sensors and strain gauge, all type of we discussed before. Here we can see the potentiometer. You can imagine why are you using the potentiometer as a the motion sensor. Potentiometer is our positional device. We can measure different position. So, we can consider as a servo mechanism. When we consider as a servo mechanism, then we are using the for the small scale motion, just angle measurement, small scale displacement measurement, we can consider motion sensor. We can discuss now the LVDT we have already discussed, capacitance discussed, strain gauge, piezoelectric just discussed. We can consider as a nozzle flapper system. This is also for measurement of the motion measurement. We can consider you have seen here as there is the supply of pressure, we can the signal pressure, this is the flapper and this conical part is your that is known nozzle. So, there is the when you change, if you apply the force or your some acceleration, some vibration, anything, any type of changes, that position of flapper it will be increase or decrease. Yeah, it will be go up or down, not left and right. It will move up and down. This is the flapper motion is also you have seen the this is the up and down. So, when you goes to the up, there is a some air will be leak. When it come down to the down, there is a no air leakage. This concept we are using in the flapper nozzle system. We can consider the motion. Yeah, the range is this is the range of 3 to 20 psi or psig. So, we can consider that because this is the pneumatic instrument, we can using the air or that time of we are using the basic unit is the we consider the range is 3 to 15 psi generally, 3 to 15 psi, but here is the mention is the pressure gauge the provides a source of throw. So, there is a some we can using rise the supply or down the supply. So, according that concept we can measure the जो motion है we can consider the, but main thing is that we can consider the flapper move upside and flapper move, there is no motion. So, there is the जो भी air है, जो भी pressure है which can decrease or we have increase. So, that concept we can consider. If you see the linearity of this flapper nozzle system, so you can see that point, this is the this region is linear. So, here is the these are the some motion sensors. We can consider motion measurement, that is vibration measurement, that is the we can consider of the shock measurement. So we can consider the special motion sensors. This is the industrial sensors, and you can see that there is the motor. There is the motor is running, so we can measure the vibration of that motor. फिर using the intelligent motion control system, this is the motor. Actually these are the motor, and this is the stator, this is the rotor, and this is the rod. So that we consider the time of the rotor. This is the wind supply. There is a continuous motion sensor wearable. You can use in the watch, you can use in the mobiles. So we can consider again the object, how we will measure the motion. So motion is state as a change in orientation of an object, as earlier discussed, and or a body which change in the time. Motion can also be defined as the change in object position with respect to the surrounding in given time. The time factor is important. So the motion of object that has mass can be represented by the distance, displacement, speed, acceleration, velocity, time. So we can consider the two type of motion, uniform motions and non-uniform motions. So if speed of an object that moves along the straight line keeps on changing, that is known as non-uniform motion. And if the object keep moving along the straight line with constant speed, that is known as uniform. Here you are seen as the at the speed, ये move कर रही है, तो we can distance here the cover, that car is covered that distance. So speed is your distance by time. So you see this application fulfilled with the help of the motion sensor. Motion bodies rectangular, circular, rotational, periodic, we can consider different type of motion bodies when we measure the motion. Thank you.